Hey everyone, welcome to one more session. Today we are going to use Python's Pandas library to read some data from S3 and perform some analytics on it and plot some charts and graphs out of that data. And we will use Python's email library to send those generated charts as an attachment to the analytics team, or as a demo we'll try to send those emails to others, and we'll see how we can achieve that easily, everything through Python. So let's get right into it. So I'm in the Visual Studio Code editor, and first thing I'm gonna do is install all the dependencies. We will need Boto3, we will need Pandas. Boto3 is AWS S3 AWS library. You can connect to AWS resources using Boto3 and perform operations on the AWS resources. Pandas is a Python library that is extensively used for data analytics and machine learning. Seaborn is a plotting library, and Matplotlib is as well a plotting library. Config parser is a simple utility or library that you can use to read the configurations from your local system or secrets that are stored in a separate file. Tablet is a library that helps you prettify your tables and present them nicely when you want to read or present your data frames. So let's install all these libraries. So since I've already installed this, it says the requirement is satisfied, but when you run this it should take a bit to get completed. Now let's import all the dependencies. I'm importing Boto3, config parser, and all the necessary dependencies that we are going to use as we go along. We will not need Matplotlib, so I'm removing that. Let's import this. Yeah, it is imported. So let's connect to the config parser. So I have a file called conf.ini where I have placed my AWS secrets and my SMTP library connection secrets as well, the Gmail username and the Gmail password to connect to Gmail server, and AWS ID and secret to connect to AWS. So if I am to call this, it should read all the configurations and place them in the respective variables. And let's create a directory. Let me delete the current directory so that will not get confused as we go along. So first thing I'm going to do is create a directory where we can place our plotted images. So this will generate a zipped plots directory here, which is empty for now. So let's first connect to Boto3, like S3, using Boto3 session. For Boto3 session, we need to pass AWS key ID and the access key, which we got it from the config parser. So to get these keys, you have to go to AWS IAM, create an user, and get the secrets from there. I presume you already have the secret key and ID, so I'm gonna run this, and it should generate a variable called session. Using this session, we can connect to S3 client, and using the S3 client we can get the object using the bucket name and the file name. Bucket is nothing but a folder, and file is a file inside the folder. So S3 is like object storage, so we have to create buckets, and inside the bucket we can place our files. So that's the hierarchy that we use in S3. So we are going to get the object out of the S3, so this will return the object in the end. So if I will call this read data function using the bucket name, which I already have in S3, let me show you how the file is placed in that bucket. So this is my S3 console, and this is the bucket which I have, and this is the file which is insurance.csv. So I'm giving the bucket name and the file name, and this method will read the file from that bucket and will place it in the file. We have that variable now. If we want to see the file now, it is like a JSON payload which gets returned by the AWS. If we see, we can see that file format, what type of the data it ranges, what is the encryption and other things. We are interested in the body flag of this JSON file, so we will only use that body to read it as a CSV file using pandas read CSV method, and we'll use com as the separator. If we load this, we should have the CSV file in the data frame df variable. So if I will be using the tablet method. Let me show you how the data frame look without the tablet. Sorry, not the markdown, we want the code. If we can see this df, we see that this table is coming in, but it's not as good as we want it to be. If we can use the tablet library, we have to pass the data frame, we have to pass the headers, like what should be the keys and what should be the table format. I'm using GitHub. We have many other formats. You're free to go to the tablet documentation and explore. So we can see that it is giving us a very good representation of the data frame. This is only my choice. If you want, you can simply present the df by printing it out, or use any other external library or third-party service you want. So we have the data frame where we have few columns: age, sex, body mass index, children, smoker, region, and charges. So let's see, we can see few of them are numerical and few of them are categorical. Let's convert the categorical columns like sex and smoker into numerical values, and we'll leave the region as is so that we can use it as a common field to plot the charts. So if I'm to describe this data frame, it only gives me all the numerical columns, it doesn't give me the categorical columns. So if we are to see, we should have only female and male as the values in the sex column, and for smoker it is only yes and no. But on region we can see southeast, northwest, southwest, and other columns. Let's see what are all the columns. Like, you can simply call that unique method on top of that column, like df, the data frame, the column name which is region, and unique is the method. If you call this, you will see all the unique values of that column. So we have currently 4 unique values of that column, which have duplicates that we are not concerned about at the moment, but we have 4 unique values in that column. So first thing we will do is we'll replace sex, like we'll replace male and female with 0 and 1. So for male we'll replace it with 0, and for female we'll replace it with 1. All we have to do is just use that data frame's column name, which is df of sex, replace male with 0, and in place is true is nothing but it will replace that column, and in place of the male it will place 0. And for female we are placing 1. Smoker, if it is yes we are placing 0, and if it's a non-smoker we are adding it as 1. So if we are to call this cell, and let's see our data frame. Now we have 1 and 0, 0 and 1 for sex and smoker columns. Earlier it was yes and no on male and female. Now it is numerical. So now if we call the describe method, it shows more columns than before. We have sex and smoker involved in the description now, and we can see some statistics like at an average a person who is of 39 years old of age will smoke more cigarettes than others. So this is simple sample data. So we are good with the data transformation. So let's plot some graphs. So first we will graph a heat map. We will use Seaborn. We have already imported Seaborn as SNS. So we'll plot a heat map using the correlation of all the columns of the data frame, and we will use a color map like yellow, green, and blue, and we will keep the annotation as true. And once the graph is plotted, we will assign a variable to that graph, and we will use that variable, and we will export a figure out of that variable, like figure, and we'll call the save figure method on top of that figure, and we'll give the figure name and the directory where it needs to be saved. We want it to be saved in the zipped plot directory, so I'm giving that directory name and the name of the plot. So heat map will take the heat.png. So if we are to run this, we have the heat map, and if we can see in the zip plots, we have the heat map file here saved as png file. So we can plot few other graphs, like first we are plotting heat map here, I will plot a box plot with the same values, and I'll plot cat plot, joint plot, and finally pair plot. This is just a sample. You can plot any graph that you want, and you can check the correlation or the relationship between the columns. So it will take a bit of time because it has to plot against all the rows and columns. So we have quite a large graph here, and this is also written to the zipped plots directory. So now, using this zipped plots directory, we are going to zip this directory so that we can attach it in the email and send it to users or your colleagues or your analytics team. For that, we are simply using the zip file library of Python, and we are writing it to this file called zippedplots.zip. This will be the file name that gets created here, and we'll write to that file. We are using this as a object, which is zip object, and we are using OS walk method that we are using to walk through this directory. By calling the OS walk, we get three variables out of the call. One is folder name, subfolder name, and the file name. So for every file name, we are using that file name, and we are joining it with the folder name, and we are writing it to the object. So if I'll call this operation, we have that zipped plots.zip file. So this is the file which have all the PNGs zipped into one. Now we are good to attach this as an attachment to the email that we are going to send. So I'm going to use Python's email library and multi-part library and MIME base methods from that email library. So if we can go back to our imports, here we can see that we have these imports that are for MIME using from the email library, and this library is very mature, and you can use this to perform various operations on the mailing part. So if we come here, we have to pass the recipients, like who are going to receive this email, and the email list. So email list is nothing but it is like simply iterating over this recipients. If we have multiple recipients, it will give you multiple email IDs, and you can use that to pass to the send mail method that we are going to see next. So we have the my multi-part method that you can assign it to a message variable. This is the method that gets used throughout the email sending part, and we can use it to attach, you can use it to format your message body and stuff. So we can use this my multi-part message variable, and we can call the subject method that adds the subject to the mail from, which is nothing but who is sending the mail to the recipients. So we are using the image directory, which is nothing but our zipped file. We want to attach this file to our mail, and we want the mail to show the name as zip plots or something else as a file name inside the mail. So you can give it any name, like whatever name you give here will be shown in the mail of the attachment. So I'm going to declare a simple body for this mail. So it does nothing but like I'm just writing a brainless query here just for fun. And for the message variable, we are attaching this body using the MIME text method, and we are making sure this body is of plain text. And using a MIME based call, we are actually using the octet stream as an output data where we want to attach our zip file. So using this part, MIME based part, we are actually setting the payload by using the zip file. We are opening the zip file as bytes and reading it as a payload and assigning it to the part MIME base, and we are encoding it with base 64. And once it is encoded, we are actually adding the header to this part by giving it as an content decomposition, and we are passing the file name, which is nothing but the file that we want it to come in the end, and we are attaching this to the message that we created in the very beginning. So using this message, we can simply send it now To send this message, we want to connect to the SMTP server, which is nothing but the Gmail server, and we are going to send it over the port 465. There are other ports. If you're not using SSL, you can use other ports as well. Please do check out the documentation. So with the server connectivity, we just have to log into the server using the Gmail username and the password that we got from our INI file. And with that authentication in place, we can simply call server.sendEmail, the message from, like who is sending the message, email list is nothing but the list of users recipients, and we are attaching the message as string here, the entire message with the attachment, and we're closing the server in the end. To get this Gmail user and Gmail password, you have to go to Google account, like myaccount.google.com, and in here you have to come to security. In the security, you have to come to two-step verification page. Once you are in this two-step verification, let me log in. So in this two-step verification, you can come to the very bottom and you will see app passwords. You can come here, you can generate an app password by selecting any of the option, and once you generate the app password, you will get a 16-digit password. You can use this password to authenticate. Before using that password, you have to go back to the main page, and here you will see that the app password was created. If you click on this, you will see an option to authenticate if it is you or not. Once you click on yes, it was me, you're good to use that password in your SMTP authentication, and you can send emails from your Gmail. So we have everything that we want. Let's call this function. So right now, if we can see, I don't have any emails other than the security alert. So if we are calling this cell, this should send us the email with the attachment. It will take a few seconds. So the mail has been sent. We can see it's a check success, and I got my mail here with the attachment, which is a 772 KB. Let me download this, and let's go to the file and unzip this file, and we have the zip plots directory, and we have all the 5 plots here as we expected. So yeah, that's about it, guys. I think this was useful for you, and please do subscribe if this was useful, and hit the like button. Have a good day.